Hi, so this is the part 2 of solving 4-bit binary input into a 7-segment output, or the binary to hexadecimal conversion. The previous video shows you the truth table, or how we derive the truth table. This time we're going to solve them using the KMAP. And as you can see here, we're going to use the 4x4 KMAP. We're shown here using the numbers or the binary bits and the position of them. And of course, it's not ABCD, but it should be W, X, Y, and Z, because they are the variables that we use. So we're just going to plot the variable outputs per column. So we're getting the column A, where we have 1 0 1 1 0 1 1 1 1 1 1 0 1 0 1 1. So you should be familiar on how we position these variables or this number into the KMAP, so that you will not have the problem or mistake in finding the simplest equation that we can use. So here we're going to use the basic gates, where there are 2 inputs and 1 output. And I circle here the groupings that we're going to use. Remember, in KMAP, we need to what? We need to simplify them, we need to group them, so that you will arrive on the simplest equation. So as you can see here, I'm correcting the variable. So for the letter A, this will be A is equal to, yan, I highlighted the letter A where I arrived this KMAP. So the final equation for this is A equal to, first circle will be the corner, so that will be X bar Z bar. So remember your derivation. Plus, what's next? Group of, I can see group of 4. So as you can see, the W is eliminated, so that will be X and Y. Okay, then the next will be another 4, and that will be W bar Y, and another 4 again, and this will result to WZ bar. It will not be redundant, because as much as possible you can use the ones that are adjacent to each other to simplify them. And of course, we have a pair, so we have W, X bar, and Y bar, and the last one will also a pair, since no more adjacent one, that will be W bar, X, and what? Z. That's it for our letter A. Okay, so let's go to our variable B. This time, instead of writing the binary numbers in the KMAP, what I'm going to use are the variable itself, so that it will be easy for you to eliminate or to see what will be the final equation. We're going to plot this letter B into our KMAP. And instead of the binary, we're going to use these variables: W bar X bar, W bar X, WX, WX bar, and so on. The previous binary, all the zeros will be replaced by the bar, and the rest will be 1. So we have y bar, z bar, y bar, z, yz, and yz bar. And plotting them, it will be 1, 1, 1, 1, 1, 0, 1, 1, then 1, 1, 1, 0, and the last is 0, 1, 0, 0. So this will be the KMAP of the variable b. And as you can see here, there are group of 4s. Encircling the first one, we have our w bar x bar plus another 4, the corners, so that will be x bar, z bar. And as you can see from the table, there will be 3 pairs, 1 and 2. This will be plus w bar, y bar, z bar plus w bar, yz. And we have the last pair. This will be plus w y bar z. So this is our equation for the column B. Okay, so now let's go to our column C. And we're going to use the same KMAP table as the one we used in letter B. And it will be plot as 0, 0, 1, 1, then 1, 1, 1, 0, then 1, 1, 1, 1, and the last will be 0, 1, 1, 1. Again, you should be familiar on how are we going to plot them in the KMAP. So we have our first quad, so it will be C is equal to WX bar. Then another quad will be this one, and it is plus YZ bar. And another quad, and this will be WY plus another quad, and that is WZ plus the last quad, which is this one. Then that will be X bar Y plus the last pair, which will be W bar X Y bar. Then we have our letter D from the truth table, and the first thing that we can find is a quad, which will be WX bar plus a quad again, and that will be WY. So the last column will be YZ bar. Then we have group of 4 again, as you can see here. That will be Y bar, Z bar. Next will be another 4. This one, that will be plus X and Z bar. And the last pair that we can have will be plus W bar X and Y bar. So this will be our equation for the letter D. You can always pause the video if you say it too fast, and you can also slow down the video. So we're going to solve for the letter E, and we're going to use the same table that we're using, the same map that we're using where it shows the variable already, because it makes it easier for you to arrive or to determine the variable that we're going to use. Here will be the first group of 4, and it will be E equal to W bar X plus another group of 4, which is W x bar plus another group of 4, which is y bar z plus another group of 4. Next quad can be w bar y bar or x bar y bar plus the last quad that we have, which is plus x bar z. The last quad is not a problem since both can be used, the top and the bottom. So, tama pa rin naman yung equation kahit mali lang yung bilog, but make sure in your paper tama yung magiging bilog nyo if you are going to use x bar y bar and x bar z. So, if i-group nyo siya sa second row, dapat tama yung inyong equation. So, at this equation, ang ginamit ko is group ko yung first row dun sa fourth row. So, we have now our variable f. The first na makikita nyo, we don't have quad. All we have are pairs. So, it will be f equal to the first pair, which is x, y, z bar. Then, plus our second pair, which is x, y bar z. Then the third pair, which will be plus w, y bar z, plus our fourth pair, which is x bar y z. And the last pair will be w bar x bar z bar. And the last variable we have, which is letter G, we have quads again. The first one, so the equation will be G equal to yz bar plus another quad, which is wx plus another quad, which will be this, that is wy, and the last quad will be the corner, and that will be x bar z bar. So this will be the truth table and the KMAP of the 4 bits binary to a 7-segment hexadecimal output. So I will prove to you that based on this equation that we can derive the correct hexadecimal conversion. So I have here 0, 1, 2, then we have 3, 4, then we also have 5, then 6, then 7, 8, and 9, then A, B, and C, letter D, letter E, and the last one will be the letter F. So base here, I use all 2 input and 1 output basic gates, and there are 4 inverters, 30 AND gates, and more or less 29 OR gates, where you will use 17404 for the inverter, then you are going to use 87408, and for the 7432 you're going to use 8 as well, for a total of 17 ICs for this project. Okay, so good luck for plotting them.